What do a battery-operated induction range?
At Copper, we make a 30-inch induction range that has a very large battery on board.
Hemp insulation.
A lot of the traditional insulation materials aren't necessarily great for you. Having a product that is sustainable, is carbon capturing, you can touch it with your hands, all of those things just really led us down that path.
A straw-based structural insulated panel.
The core innovation is the insulation composite. It's a loose straw composite mixed with a bio-based binder, fully non-toxic binder.
A whole life carbon visualization tool.
Now you see we've just reduced energy use emissions over 60 years by 80% by doing those two things. So that's huge, right?
And a product transparency software have in common?
We are the only end-to-end product transparency solutions provider for building product manufacturers, and we get their products into projects and libraries.
Well, for starters, they were all at this year's Greenbuild conference. But more importantly, they're all key pieces of the puzzle when it comes to reducing the carbon footprint of the built environment and making it healthier and more resilient. From the products and solutions on the expo floor to the session topics at Greenbuild this year, it was clear there is a resounding urgency to adopt whole life cycle design thinking and simplify and streamline the specification and procurement of sustainable and healthy materials. And Copper, Green Fox, Verdant Panel, C-Scale, and Sustainable Minds are some of the innovators working to pave that path.
At Copper, we make a 30-inch induction range that has a very large battery on board. That allows you to do a bunch of different things, but one of the main value propositions we find that people really enjoy is that when you're getting rid of a gas stove, normally you'd have to rewire a house to get a 240 volt outlet on a 50 amp breaker. That can be incredibly expensive and complicated to do. Instead, with our battery-equipped induction range, you just plug into a normal wall outlet. So you just plug into a 120 volt outlet that was behind the gas range there already, and you're done. The installation is done. So you take all the cost and complexity of rewiring a building, doing a panel upgrade, service upgrade, make it a plug-and-play installation. So super easy and one of the cleanest, neatest ways to make that transition from gas to electric. And in the end, you get a brilliant luxury cooking experience because you have induction cooking, a high-powered, precise oven, and also the only electric stove that works when the power goes out. If you're cooking a giant meal, the stove can charge while it's also using the battery. And so you'll get about 8 hours of cooking, kind of non-stop cooking while it's charging and in use at the same time. If the power goes out, you're looking at probably 3 to 5 meals of cooking. If you were to use it all at once, you can scramble about 600 eggs in one go, back to back to back, if you have 600 eggs on hand. And then if you're talking about the total lifespan of the battery, it's lithium iron phosphate, which is a very stable battery chemistry. It lives for a lot of life cycles. And so you're looking at about 15 years before it is reduced to 80% nameplate capacity. Because the battery is so large relative to a normal cooking experience, most people won't notice that degradation and they'll keep it. But if you're someone who cooks a lot and you're like, hey, I want to replace it, that's great. You can swap your battery after 15 years if you're still using the device.
So how did this idea of incorporating batteries into appliances even come about?
So we started with a grant from the Department of Energy to research deploying batteries at the edge of the grid, looking at this problem that exists out there that if we're going to electrify everything, if we're going to get rid of all our gas burning devices, it's going to cost a ton to rewire all the buildings and get the electrical load and service capacity necessary. And so we need to deploy a bunch of batteries. And the most cost-effective way to do that is to put the batteries into a device at the factory rather than doing a bunch of custom rewiring work on a building or rebuilding the grid in order to have those batteries energy reach the end use. And so if you just put them in a factory and have that battery serve the load that it's attached to, it's a very cost-effective way to deploy batteries. And so at the end of that DOE grant, it became very obvious that doing a stove is one of the best ways to do this because it is a very spiky energy load. So you can reduce that spike, smooth it out, and then shift a lot of power use to when you're generating renewable energy. So it becomes a great way to lower a building's total power requirements and shift an electrical load to from what would otherwise be peak use time to peak solar or hydro availability. Originally, we were naming it as like Alpha Bravo Charlie. This is kind of the third iteration of this product. And then as we were kind of looking at what are we going to name the product, well, Charlie comes from Charles, which is the free man, and we loved, it means free man, and we love that concept of, oh, this stove helps you break free from your fossil fuel connection. And so that was very nice. And then At the lab where we had done a bunch of our research, other lab in San Francisco, Charlie was the accountant, and so it's a gender neutral name and familiar. It takes also a kind of old classic name and makes it familiar and kind of contemporary, and we wanted to have a design that reflected that as well. So there were a lot of reasons that it just felt like, hey, this is the right name for us to give to the product. Every Charlie has its number engraved on the top of the door, and we wanted to do that because it's this kind of sense of everyone can have one, but this one is yours. This numbered one is your specific Charlie, and there's that kind of sense of being part of a big movement, of something that's bigger, and this is your individual contribution as part of that big movement.
Green Fox was founded off of really kind of a principle or belief of wanting to take the crops that we're growing on our farm and take them to market, both for the grain side of things and the sustainable building side of things.
It started by wanting to vertically integrate our farm to final products, to finished goods, and doing it in a very sustainable way.
We have a farming entity. Rookie Farmers is our farm, and we run about 6,000 acres. When we first started the farm, we were growing really more of the traditional, conventional crops. And we wanted a way to really diversify the farm, and so we started looking at non-conventional crops, and one of those was hemp, and really because it fits so well within our crop rotation. It is carbon capturing, it is helping the soil to heal, and then out of that crop you can utilize really every portion of it, from the grains to the fiber, and you can make products that people can use within their homes. They can consume them. They're good for you. They're good for the planet. It was really just about figuring out how it is that we can utilize that entire crop, and so insulation just seemed to be the one where we felt that there was a significant need for it. Insulation is something that you don't necessarily think about. It's behind the walls of your home. And so you're incorporating it into your everyday world, but you don't really necessarily know it. And a lot of the traditional insulation materials aren't necessarily great for you. And so we really feel like, having a product that is sustainable, is carbon capturing, you can touch it with your hands, you don't necessarily need to wear PPE when you're installing it. All of those things just really led us down that path of choosing building materials.
Ever since we've owned the farm, we've been integrating more regenerative type practices every year, to the point where last year the vast majority of our acres are now regenerative certified to verify our regenerative practices, which is one of the main ones is just having living roots in the soil at all times. So as soon as we harvest a crop, we plant a cover crop, for example, or the next crop, so that through the winter the roots are growing, the soil is healthier, and it literally reduces all the erosion from wind and rain and snow, etc.
We utilize the full plant, and so when we bring in basically a bale of hemp, we are processing that through a system of a decortication process, and that's really separating the fiber from the hurd or shiv. And typically that's used for things like animal bedding. It's also used in hempcrete. You can use it as mulch in your garden. So there's a lot of different things that you can use with that. On the fiber or non-woven side of things, really right now our primary focus is on insulation and acoustic panels.
I was running Verdant Structural Engineers, and we were helping people with permit acquisition work for alternative building materials, one of them being straw construction, full bale straw construction. And I had a number of ideas I wanted to put forth, and one of them was an optimization of straw panels. We had been being asked to work with very customized straw panel systems, but very specific to the needs of the client, and I thought if I could think about this, if I could take a step back and think about this, not just associated with one specific need of a client, we really could possibly scale this and take it somewhere. And so we got the phase 1 grant for $100,000, and then we ended up getting the phase 2 grant for $400,000, and $500,000 later we spun off my second company, Verdant Building Products, and we are in the process of deploying our phase 1 early adopter products to the market with this performance equivalent to conventional insulations using this ubiquitously available non-toxic agricultural byproduct. Right now it is a SIP. And it's a fully code compliant system. The gravity and the earthquake and wind lateral system are just standard wood construction. But the core innovation is the insulation composite. It's a loose straw composite mixed with a bio-based binder, fully non-toxic binder, and that we just received the patent on. And it's the binder that's the magic sauce that allows us to really optimize the fiber gradient to increase the thermal resistance capacity. Currently, we're deploying a SIP panel, but our other verticals that we're exploring are the options of a bat replacement, of being able to work with the composite free of the prefabricated panel. That's the good news, though, that we can now build straw buildings that don't have to have an aesthetic that is different than your neighbors, or a wall thickness that is different. You know, you can build full bale straw construction with similar aesthetics, but you cannot get away from the wall thickness. The insulation is on track to be performance equivalent to conventional insulations, fiberglass, blown cellulose. So whatever thickness you use those systems for in your region, that's the thickness you would use this for. And most commonly, that's a 2x6 wall.
Scale was developed at an architecture firm that I was at for 23 years, EHTD in San Francisco, and we developed it in-house just as a tool to help us figure out how to have the biggest climate impact on projects from the very beginning, when you didn't know what you were going to design yet and you were using intuition. We wanted to bring data to that process and have a tool that actually helped you understand, was it all about electrification, or maybe switching from concrete to wood, or building reuse? Like, what were the big levers to use early on when you can make big impacts? So we built a tool, we put it out for free on our website, got about 5,000 users within a year or two. And after a few years, we ended up spinning out a company separately, raising some venture capital, climate tech funding, and building kind of what you see now, C-Scale. One thing our users like to do is, right when you get an RFP or you just win a project, how do you actually get insights really fast to help you with that direction? So let's say we're here in LA, so let's say it's a LA school and it's new construction. Maybe it's going to be done in 2029, and you could give a specific address, but for now I'll just say Los Angeles, and it'll fly down to Los Angeles. And then, so I said it's a K-12 school. Maybe it's 2 stories, and let's just say it's 50,000 square feet. That's all the information you need, and within seconds it's building a baseline building. It's saying, okay, a typical 50,000 square foot school over 60 years would have this much embodied carbon, this much emissions from on-site combustion, and this much electricity emissions. And you can also look at that over time, saying that you can see right up front, the upfront carbon, the embodied carbon, is 650 kilograms. And then over time, each year, adding on top of that is our emissions from energy. You can adjust things, you could adjust some of the assumptions if you wanted to, but let's just assume the assumptions are right for now. Let's just look at energy first and think about how do we reduce those energy emissions. So I'm going to go here to energy use and see that the baseline energy was assumed to be 69 kBTUs per square foot. This is coming in from something called Zero Tool. Let's look at what if we wanted to reduce energy use by 50%. So you can see, basically, over 60 years, we've reduced energy emissions by about half. But it's still a lot of fossil fuel emissions. So what if we went all electric and we relied on the grid, which in California is very clean, a lot of renewables, a lot of wind. Now you see we've just reduced energy use emissions over 60 years by 80% by doing those 2 things. So that's huge, right? Well, what if in addition to that, I wanted to look at materials and embodied carbon. So let's just rename this one maybe energy and materials. We'll save that. And let's look over at this image here. So we can see, okay, energy, this is the different sectors of where the emissions are coming from. You can see structure is definitely the big one now that energy was dropped down. So let's click on structure, and we see that it assumed a concrete building, which we could see what happens if we just use low carbon concrete. And it says you could have some improvement there, but even bigger, what if we actually did a wood frame spool? Well, it's saying you could reduce emissions by about 39% from the baseline. And if you use responsibly sourced timber, you start to see something called stored carbon below the line. So that's from sequestration. You could also click through there's other things to consider here, like looking at your building enclosure. So that's the next biggest element. And again, low carbon, we can see that we could do a 27% reduction. Now, we're not yet looking at what is the actual enclosure, like is it wood, is it brick? That happens later, but within the tool you can build on this kind of early phase insights and then start to analyze in more detail, well, what kind of wall actually could achieve this? What if it's metal panel? What if it's cement plaster? What if it's wood siding? And then eventually be able to say, well, okay, it's a metal panel wall. Which metal panel is actually the lowest carbon? And be able to add that to your project. But at this stage, you can see here are the different scenarios. You can compare them against each other on a category level or what's called lifecycle stages. Or just at a high level to understand how these three scenarios stack up. And then you could do things like export or report to AIA 2030.
I started Sustainable Minds because in my research for building this marketplace of great green products, well, in 2006, 2007, there weren't a lot of great green products in the marketplace. Well, why is that? Because nobody cared. Green wasn't even a thing. I thought we could make an even more impactful company if we could build a company that delivered tools with the knowledge built in for manufacturers of any kind of physical product to understand the life cycle impacts of their products in early stage design so they could actually make greener decisions from the start, understanding where in the life cycle the impacts were occurring. And we launched that product, and in 2009, it became available to the marketplace. So we have been very successful in getting that tool not only early into industry, but largely into higher education. So today, that tool has been used and is being used in over 500 colleges and universities around the world, teaching business, design, engineering, to teach people to think from a life cycle perspective and be able to design products differently. So in 2012, when LEED version 4 introduced the pilot credits for EPDs and material disclosures, we already were in the simplified LCA business and also in the business of making LCA's information understandable. And so we saw the opportunity to create a new kind of EPD that would make the technical information understandable about what is the manufacturer doing to actually improve the environmental performance or to reduce impacts. And so we developed we call our transparency report. It's an EPD. Then in 2016, when there was a very slow uptake in the manufacturing industry around EPDs and material disclosures for LEED, we had the idea to launch the Transparency Catalog to create a destination for organizations really looking for high performance materials, so products with EPDs and material disclosures, to come one place and find every manufacturer anywhere in the world making products for the North American market who had invested in EPDs or material disclosures, all organized by master format. And for those manufacturers, showcasing, really shining the light on those who had spent the money, the time, taken the risk to literally reward them for doing that. And so in 2016, we launched the Transparency Catalog with 350 manufacturers. That's all there were anywhere in the world with EPDs and material disclosures. And today we have over 2,300 building product manufacturers and industry associations in the catalog with a lot more content, a lot more functionality. And our latest announcement for Greenbuild is now to have real-time reporting for status reporting for LEED version 5 and the AIA material pledge. So our primary users of the catalog are architects, engineers, contractors, real estate owners, facility managers, now code officials, people looking for products with EPDs, material disclosures, low emitting certificates for building high performance buildings. And the other users are building product manufacturers who have published those kinds of disclosures and want to be sure that they're getting their products in front of those people who are really motivated to select, specify, procure, and install those products. And now with our latest application, people can source materials from the Transparency Catalog and build their own internal digital libraries and projects of these preferred materials. For what we're doing, as a mission-based for-profit company, we're actually engaging with and enabling the people who can make a difference to make that difference. So that's exciting.
To borrow from Terry from Sustainable Minds, each of these innovations is enabling the people who can make a difference to make a difference. And these are just some of the practical, market-ready solutions available to help the AEC community address embodied and operational carbon and create healthier environments for people and planet.